In this exercise in polar coordinates, we find the area of the region in quadrant 1, and that is inside the rose curve r equals 2 times sine 2 theta, but is outside the circle r equals 1. The region whose area we are looking for is shaded green on the diagram. Given a region that is bounded by the graph of r equals r of theta, and is between the rays theta equals alpha, and theta equals beta, with alpha and beta between 0 and 2 pi, and alpha less than beta. The area of the region is given by half times the integral from alpha to beta of the square of r of theta. To get an idea as how to set up the integral for the area of the region, we draw a radial line from the origin and extend it to the circle, and then beyond all the way to the edge of the petal in quadrant 1 of the rose curve. The area integral formula given on the right is for the whole area that extends from the origin all the way to the graph of r equals r of theta. Directly plugging in r equals 2 sine 2 theta for the rose curve into the integral formula, we will end up with not just the area of the green region. The value that we eventually find will be the area of the region being swept by the radial line from one point of intersection to the other point of intersection between the two curves. We will end up with the area of the union of the green region and the orange region. First, we need to find the theta values at the points of intersection between the two curves in quadrant 1. We set the r value of one curve equal to the r value of the other curve. And so we have 2 sine 2 theta equals 1. Or sine 2 theta equals 1/2. Since we are looking for 2 points of intersection in the first quadrant, we must find the first couple of positive values of theta and verify these values against the graph. If sine 2 theta is equal to 1/2, the smallest positive value of 2 theta is pi over 6. Then we have 2 theta equals 5 pi over 6. And so dividing by 2, theta must be equal to pi over 12 and 5 pi over 12 in the first quadrant. Theta equals pi over 12 is easy to verify on the graph. This must be the point where theta equals pi over 12. And this must be the point with theta equals 5 pi over 12. Since 5 pi over 12 is just pi over 12 short of pi over 2. And so these theta values are the correct limits of integration. Therefore, the area of the orange region must be equal to half times the integral from pi over 12 to 5 pi over 12 of 1 squared. R of theta being equal to 1 on the circle. As an easy exercise, the viewer can check that this is equal to pi over 6. Using r equals 2 sine 2 theta for the rose curve, we find that the combined areas of the orange and green regions is equal to half times the integral from pi over 12 to 5 pi over 12 of the square of 2 sine 2 theta. As an integration exercise, the viewer can check that the combined areas of the orange and green regions is equal to the quantity 3 square root of 3 plus 4 pi all over 12. From this, we subtract pi over 6, which is the area of the orange region, to get the area of just the green region. And so the area of the green region is equal to the quantity 3 square root of 3 plus 4 pi all over 12 minus pi over 6. This is equal to the square root of 3 divided by 4 plus pi over 6. This is approximately 0.957.